Well, this is my favorite subject. I have a long history with psilocybin. I would like to ask first, and it's a legally legitimate question for you to answer. So, how many people here have not taken psilocybin mushrooms? Oh, young Jedi. The mycoverse awaits you. Okay, so I could carve that up in different ways, but that subset's good enough. So I think mushrooms are, for me, a gateway into infinity, into the divine. And I have postulated this for a long time. And Rupert, I'm super honored to have finally met you, and you're very gracious and generous in your comments. But this whole thing on quantum theory and the multiverse, it's just getting more and more credible in my own life as time goes on. So without further ado, I'm going to take you into some extraordinary research that others have been doing, some of the research that I have done. And I think it's opens up, a new understanding of the quote unquote reality that we all share. So, are you on the bus? Yeah. All right. Well, now you're on the bus. Let's take the next quantum leap in human consciousness. So, another voyage into the microverse and the paradigm shift. First, I want to just give you a super brief description of the mushroom life cycle. When you see mushrooms, fleshy mushrooms, they're highly perishable. They're only up for 5 or 7 days, maybe 10 days at most, and generally before they rot. It's the mycelial underground that is resident in the ecosystem for literally years, months, even decades, hundreds of years, sometimes before these mushrooms surface, and then they reproduce. Mushrooms produce spores. Generally speaking, 2 spores come together. They're sexually compatible. They mate. And, come back here. And when they mate, then if they're compatible, then the mycelium is binucleate, 2 nuclei per cell, and then it's fully capable of producing fertile offspring. So this stage of the mushroom life cycle is very, very short. This stage is 95 to 99% of the life cycle of the organism. Here is a time lapse of Psilocybin cubensis over 5 days. And the mycelium is growing out and is constantly diverging. And at these tips is where is a fertile area for epigenesis. The tips of mycelium become multinucleate. They're exploring as a really rapid cellular reproduction. And think of them as like little scientists that are coding and meeting new potential food sources, a new adversary, and a pollutant. Because of epigenesis, which is basically the elicitation of a genomic expression from an external environmental stimulus. If there's a new coding, then that in the enzyme that's being produced, the antibiotic, whatever the case may be, if it gives benefit to the mycelium and allows it to have more food, then what happens? The information back channels into the mycelial network. So these are self-learning membranes. They pick up knowledge. They're constantly experimenting, and they are so adaptive to catastrophia. And since we're the greatest walking catastrophe I know on the planet, they walk behind us, literally picking up in the debris fields that our footsteps create. Interestingly, many, if not most of the psilocybin mushrooms are associated with human activities. This is not an accident. I think these are trail followers, and I think they're calling out to us at a time critical that we need to listen to them. The largest organism in the world so far is a mycelial mat in eastern Oregon, 2,200 acres in size, over 2,000 years old, and it's 1 cell wall thick. Now, I'm a microbiologist by training. We do what's called colony-forming units. Basically, we count how many microbes there are in a gram or a milliliter of water or a gram of soil. It's really common to get 1 million to 10 million, 50 million microbes per gram. Soil literally is a living population of microorganisms. So you consider this as 2,200 acres in size, the largest organism anywhere in the world. It only has 1 cell layer, on the other side of which are all these hungry microbes, many of which would like to consume it. How is it possible? It's possible because of epigenesis, and that these have innate immune systems that over millions of years have developed the strategies to be able to defend themselves against predators and be able to conquer great landscapes. So the mycelium, I spent many years as a scanning electron microscopist. I'm going to show you some of my electron micrographs. And so the mycelium, under 4 primary stimuli, forms mushrooms. So the mycelium grows and then after occupies a certain niche or so. If there's an introduction of water, well, we all know that, it rains. And when you have rain, you have evaporative cooling, so you have a dropping of temperature. Third, as the top of the soil gets wet, the mycelium, reaches the tops of the soil and then exhales carbon dioxide, inhales oxygen. The CO2-rich environment of the soil is not conducive to mushroom formation, generally speaking, but when it comes to the surface, it then exhales carbon dioxide, inhales oxygen. So the third stimulus is exposure to oxygen. The fourth one is quite surprising to many people, is light. 99% of all mushroom species require light. They have no chlorophyll, but they're phototropic. The button mushroom you buy in the store is really unusual because it's not light dependent. So those 4 environmental stimuli, introduction of water, dropping of temperature, exposure to oxygen, exposure to light, then can trigger mushroom mycelium to form mushrooms. The absence of which, you can age that mycelium for a long time and they won't produce any mushrooms. Primordia are little baby mushrooms. They form. Now, these cells are highly multinucleate. It's exploding, rapid growth. And then the mycelium aggregates to form a baby mushroom. Now, there's so many interconnections with bees here, but blue light stimulates mushrooms to form, 320 to 400 nanometers. We can see down to 400 nanometers. Bees can see down to 300. What I didn't mention in my bee talk is that I speculate, hypothesis, not proven, is the bees are cruising through the forest looking for these wicking veins of mycelium coming up because they give them access to something called p-coumaric acid that activates the cytochrome P450 pathway. All animals use that. There's detoxification pathway. P-coumaric acid coming from wood is the only chemical that activates the bees' detoxification pathways. Without p-coumaric acid, the bees can't detoxify. So neonicotinoids, pollution, all that stuff builds up and makes them sick on top of the viruses. So that's another sort of connection here. So I'm wondering if the bees are actually looking for blue mycelium because that's in the ultraviolet range. So here's a mature mushroom. The mushroom rots. A few days later, I go back. My foot is covering, there's about 8 miles of mycelium in a single inch of soil. I estimate my foot covers between 300 and 600 miles of mycelium. That's how pervasive it is. These this is the not so invisible landscape underneath every foot that you take. So when you're walking across an ecosystem, you're leaving impressions on these highly evolved, fungal fabrics that are responsive. They know that you are there. These are highly evolved sensory membranes. And because of the competition for food, if you break a stick, a lot of fungi want to get that new wood access. And so they leap up in competition. So generally speaking, first to food wins, and communities survive better than individuals. So the mycelium sets up the microbiome. I've done next-gen sequencing of mycelial networks and found up to 1,000-fold difference in the relative genera of bacteria from the same wood chips colonized by one mushroom species versus another. I've never published this, but this clearly shows that the mushroom mycelium sets up the microbiome in the ecosystem that is resident in the ecosystem that gives rise to the foliage and the trees that create the debris fields that feed the mycelium that protects the progeny of the fungal species that are dominant underneath the tree. So they're actually deterministic in setting up the ecosystem landscapes. So much of the mycelium is these extracellular digestive enzymes, which are basically for getting food, but they also contain antibiotics, antiviral compounds, messenger compounds. They're extremely complex. There can be more than 1,000 species of bacteria existing in a single gram of soil. So the majority of bacteria are adversarial to mycelium, but the mycelium got very smart very early and created mutualistic relationships with commensal bacteria. So then by having this commensal bacteria that are mutualistic with the mycelium, the antibacterial properties from those bacteria then also would help to defend the mother mycelium that sets up the matrices to create the microbiome that ensures those mutualistic bacteria have a better advantage against their competitors. It's very complex. The mycelial networks, pervade these little cavities. There's no specific place you can harm the mycelium. Here's a vein of mycelium surfacing in the woods. So as a result, there's always an alternative pathway for the mycelium to be able to, if there's a break, there's an internal pathway for the mycelium to be able to stream nutrients. When you break mycelium, it forks. So it's one of the few organisms that benefits from concussion. And mushroom growers long ago figured out that when their mushroom beds stop producing, they can take a rake and they can rake the mycelium to break it. And then a flush of mushrooms will come up. So it's one of the few organisms that actually benefits from disturbance. My friend Patrick Hickey made these movies. They're extraordinary. We didn't know that the nuclei flew in bundles or streamed in bundles. Hundreds of nuclei stream through these networks. Look really carefully. They're not all going in the same direction. There's about 2 to 4% of them are going reverse cytoplasmic flow. We suspect that these are kind of packets of DNA with knowledge in them to help educate the rest of the mycelial mat. So I'm going to wax poetic. I've talked about this for a long time. And as I mentioned, I am becoming more and more convinced. There are some truths in nature that are universal. You just know that makes sense. That's right. Self-obvious universal truths. And this is one of them. The organization of neurons mimics that with the same archetype as that of mycelium. The organization of the computer internet also conforms the same archetype shared by mycelium. And let's go back to the very origins of the universe. 13.8 billion years ago was the Big Bang. All this star matter exploded throughout the cosmos. And then this is from the Max Planck Institute after the Big Bang. You'll see these parsecs change. 1 parsec is 3.26 light years. You're going to see the greatest expanse of the universe so far presented in a computer model. So that's 3.9 megaparsecs. So in light years, and now we're going to go back. Those are galaxies and stars, and then you begin to see dark matter, and you go further and further out. The greatest expanse of the universe also conforms to that of network theory, and that sharing the same archetype of that of the mycelium. So you look at dark matter through the Deep Hubble telescope. There's I think 180,000 galaxies in this one deep field view, and the cobweb of dark matter nets them all together. As most of you know, more than 90% of the matter in the universe cannot be seen. But this does explain why the galaxies are spreading further apart and not contracting. So we go to 4.5 billion years ago, the Earth coalesced out of stardust. And then after 4.5 billion years ago, about 200 million years later, many of you may not know this, we had a visitor, a Mars-like planet, came and slammed into the Earth, planet Theia. Planet Theia slammed into the Earth, enormous rubble field occurred, it coalesced and formed our moon. And so this is when the Apollo astronauts went to the moon and came back. They were astonished that the mineral profiles were the same as that as Earth. And so that gave substantiation to the formation of the moon with planet Theia. And Bruce gave a great talk yesterday about interfaces and tidal poles. He's so right on. Because with the moon, then we had a tidal fluctuation at the interface environments. Life came from the sea onto land because those margins were kept on changing. Well, the last universal common ancestor is 3.8 billion years ago. It's a single-celled organism called Luca. Oh, hell, Luca! No, I'm sorry. You have to have seen Dr. Strangelove to understand that joke, okay? If you haven't seen Dr. Strangelove, you should watch that clip. You'll understand. Okay, but so Luca was a single-celled organism. So we march forward to 2.4 billion years ago in South African lava, just recently discovered. The first evidence of a multicellular organism was that of mycelium. Now, animals split from fungi. Fungi gave birth to animals. 650 million years ago, a new super kingdom that's been erected by scientists called a Psilocybin. That's when fungi and animalia were joined. 650 million years ago, fungi gave birth to animals. Animals went, encompassing its food in a cellular sac, and the fungi continued to externally digest its nutrients outside of the cellular network. So 1.8 billion years later, this means we are descendants of mycelium. We are descendants of fungi. These are our mothers and our fathers. So we go forward to 420 million years ago, discovered in Quebec and Saudi Arabia and elsewhere. 1843, the fossil was given the name Prototaxides. It was over 10 meters, about 35 feet long, 40 feet long. Laying down was a meter high, about 3 feet high. And at that time, this is before vascular plants, before flying insects. There were ferns, but even at 3 meter high, it's the tallest organism on land 420 million years ago. Well, these were in fact standing up. And Dr. Kevin Boyce determined what these were because they were a mystery for over 100 years. Because people thought they were trees, but the tree hadn't evolved yet. And they turned out to be giant fungi, dotting across the face of the earth, the tallest organisms on land, with these pillar-like fungi that would attract lightning, electromagnetic fields, obviously, a lot of lightning strikes. It would strike the highest points on land. Perfect place for epigenesis, rapid evolution, stimulation of electricity, microbiomes being established. And then we go forward to about 250 million years ago at the Permian-Triassic boundary, and we have another celestial visitor. And this comes in. Now, this caused a great extinction event at the PT boundary. And there's 3 competing theories: an asteroid impact. There's earthquakes that could have jettisoned methane hydrate from the ocean, or there is volcanoes in Eurasia that spout up all sorts of debris. I don't think them as mutually exclusive. The asteroid impact could have happened first, created the earthquakes, caused the fissures in the ocean, all this gas and debris jettisoned in the atmosphere. We had a massive extinction event. The Earth was shrouded in dust. Massive numbers of plants and animals died, and fungi inherited the Earth. Now, the Permian-Triassic boundary is really distinct, before and after. And actually, in the fossil record, they found the dominant fungus at the PT boundary was given a name, Reduviosporinites. So this is the one that gobbled up the majority of the forests. It's dominant in the fossil record directly at that margin that you saw earlier, and that's the dominant fungus that was found. So those organisms that paired with fungi had a better chance of survival because the fungi were growing underground. As fungi decompose debris, it generates heat. There's an exothermic reaction. You all know this from compost piles, etc. So even with those giant debris fields and the earth is shrouded in dust and temperatures plummeted, the soil layers were cooking because of thermogenesis and the exothermic reaction of fungi gobbling up the debris. We go forward to 400 million years ago, time of Pangea, Gondwana land, and you have separation of the continents. And I like to reflect. And when I was in the 3rd grade, I raised my hand in geology class. And I said, "Teacher, that looks like the continents all fit together as a puzzle." And she goes, "No, it's a coincidence." I think scientists better listen to 3rd graders more often, right? So we go forward now, and this was just recently discovered and published 110 million years ago. This is, they're in the sediments, and mushrooms are very decomposable, so it's hard to find mushrooms in sediments, but they found one, and they give it a name, Gondwana agaricides magnificus, 110 million years ago in the early Cretaceous in Brazil, a perfectly shaped mushrooms. Why I'm showing this is that mushrooms are ancient organisms. Mushrooms had their forms long before we had ours. And so we advance forward now to 65 million years ago. You all know this story. We definitely had an asteroid impact in the Yucatan area. And a huge extinction event. Thank goodness the dinosaurs became extinct, in my opinion. After watching Jurassic Park a few times, but the same thing. Debris fields, shut off the sun. Massive extinction. Fungi then re-inherited the Earth. There's a repeating theme here, folks. If you want to survive extinction events, pairing with fungi give you a better chance of survival, and that's what we are faced now today. So we'll look at the Earth today, and we'll jump way forward, but let's talk about primates. There's 22 primates that are known to consume mushrooms. 23, including humans, were primates. And the Golgi monkey consumes 12 times its body weight in a year. Americans consume about less than 3%, 1.9 kilograms. So these primates know the difference between edible and poisonous mushrooms. They are dependent, upon them for sustenance. And the reward of natural evolution, the better you know your environment, the more food you have, the better chance of survival. Well, that's, I think, speaks to a very ancient, broad knowledge of the coevolution of fungi and animals and coevolution of fungi and primates leading to us. Now, I'm not sure if Rupert's in the room. Rupert, are you in the room? I don't know if he is or not, but he nailed it. He just said something, 200,000, 2 million. Exactly right. The Homo sapiens brain suddenly exploded. And basically, the limited number of fossils, we can't calculate this exactly, but the human brain suddenly increased 2 to 3-fold between 200,000 to 2 million years ago. And how and why? Now, in the evolutionary context, that's really, really quick compared to the evolution of other animals. So what caused the human brain to suddenly expand? And I want to resurrect something that Terence McKenna and Dennis McKenna brought up called the stoned ape theory. Now, Homo sapiens were late arrivals in Europe. They came in around 40,000 years ago. Homo erectus and Neanderthals were there first. But within 4,000 years of contact of Homo sapiens, they did 2 migrations. The first migration failed. The second migration of Homo sapiens was successful 40,000 years ago. Within 4,000 years of contact, we made Neanderthals extinct. And Homo erectus became extinct. If you've done a 23andMe test, I'm 3.5% Neanderthal. I'm proud of it. Can you tell? I'm kind of a hairy guy. So now the expansion of the human brain size also was correlated to climate change when there's a study, a drawing of the climate. So Terence McKenna, was a good friend of mine. And I love Terence, especially the last 5 years of his life, because he made fun of himself. But as Dennis said, if only 10% of what Terence said is true, then his contribution is enormous. And I will tell you, and I've told Terence, time wave 0 was total bullshit. If you know about that, he had the end of time happening on his birthday. And he said that the birth and death of Christ was not a historically significant event because it was anti-Christian. I'm sorry, Terence, that just does not wash with me. But this does. And bless his heart, he came up with something when he was tripping on psilocybin mushrooms in South America. And it's a stoned ape theory is what he calls it. So this is a little clip. Louis Schwartzberg and I are doing a movie together. And the stoned ape theory, as he postulated, our hominid ancestors, due to climate change, would come out of the trees, go across the savannas. You go across the savannas, you're tracking animals. What do you find? Scat, poop. You release down what is the largest mushroom growing in poop, and common in the subtropics is Psilocybin cubensis. You're hungry. The majority of primates eat grub, insects laying eggs and mushrooms. The primate eats these, and suddenly they have this amazing expansion of consciousness. They're sharing it with their friends, their family. They're having a unity of consciousness. The floodgates of the sentence open up, and it leads to neurogenesis, the building of new neurological pathways. And so the brain then suddenly began to evolve. Now, how many times would this happen? Well, think about it. You're a hunter. You look for footprints. You look for scat. You find mushrooms. You're hungry with your clan. This will not happen once, twice, 10,000 times. But millions upon millions upon millions of times over millions upon millions of years. The opportunity for epigenesis is so profound that this is not a possibility in my mind. But as Bruce mentioned yesterday, this is a probability. If the field of data is large enough, the improbable becomes likely. So, Psilocybin cubensis grows on elephant dung. Look how big that thing is. You're hungry. It's fleshy. You consume it. It bruises bluish. You very quickly realize that these bluish mushrooms give you, an extraordinary state of mind. So, and the other mushroom that grows with is Copelandia cyanescens, or bispora. And these are also psilocybin active mushrooms. So you have a minor player and a major player. Okay, so it is not a theory. It's a hypothesis. But just to be clear about this, psilocybin degrades into psilocin, it tightly binds and activates serotonin receptors, stimulating neurogenesis. It's a serotonin agonist. It substitutes for serotonin. Now, the very interesting and bizarre thing is that mycelium produces serotonin. And these are neurologically framed networks that are benefiting from epigenesis. So I have all these debates with my older brother, Bill, and I stated in one of my books that I believe nature is intelligent. I go, you can't say that. You'll be mocked. That's academically indefensible. He's very much smarter than me. So I'm always on the defensive, like, whoa, calm down, Bill. So I thought, wait a second, Bill. You're saying nature cannot be intelligent, that humans are. I said, you know the hypocrisy of that statement, that you're using the brain that nature gave you to articulate the ridiculous argument that nature is not intelligent? He looked stunned. I said, I'd rest my case. I needed to back out of that conversation as fast as I could. He's much more, he would come up with a clever answer. So I wanted to. Okay, so it's not a theory, it's a hypothesis. A hypothesis is an educated guess to explain an observable phenomenon. A theory is a hypothesis that has been tested by science and factually supported. Now, I'm saying this now, but as evidence builds, the hypothesis of the Stone Date theory, a Stone Date may become actually a theory, because the evidence is becoming overwhelmingly favorable on neurogenesis. So, a number of scientific studies. I'm a science nerd, and so a lot of studies. In fact, one study just came out yesterday that I'll be talking about. But the extinction of the conditioned fear response, and this was with mice, and they were associating pain with a sound. And so then when they heard the sound, they cowered in pain. They dosed them with mushrooms, and they had a dissociative response with the sound. They were able to dissociate the fear-based response to that stimulus. So it was an opportunity to realign behavior. So anyhow, the low doses of psilocybin facilitated an extinction of the conditioned fear response to life-threatening events. Okay, you're a hominid. You're going across the savannah. Saber-toothed tigers attack your clan. Devastated, your clan barely escaped. You trip on these mushrooms. You think, well, next time I'm not going to let this saber-toothed tiger attack my family. So it dissociates you and makes you then potentially more courageous. Psilocybin induces courage and kindness. People want to support leaders who are courageous and strong, but have their best interests in mind. They know they have the benefit of the commons is more important than their own individual benefit. Those are the leaders we need, and those are the leaders we respect. And I can think of a few leaders right now who could benefit from dosing themselves on psilocybin. Donald Trump, don't invite me to a White House dinner. Oh, yeah. Or please do invite me to a White House dinner. These are leadership skills. And it makes you into a better citizen. Why? Well, this is the great, and Nancy Reagan, bless your heart, but which brain do you want, Nancy? The placebo or the one on psilocybin? It's a connectogram showing increased intercommunity crosstalk after psilocybin ingestion, even though there's more nodes of crossing. Even though that the brain doesn't light up as much, there's a lot more crosstalk between the individual brains. So I wanted to go forward to the bee shaman. This is about 5,000 year BCE in northern Algeria. The first image you'll see is the actual cave art. It took forever to find this. Then a friend of mine, Jonathan Meter, redrew it. There's the actual cave art in northern Algeria. Now it's being redrawn to be true to form. And this is really interesting. There's a long association of putting magic mushrooms in honey, especially in Mesoamerica. But in 1516, under the pressure from the Catholic Church, mushrooms were banned from beer. And so there are psychoactive meads practiced being ingested by Germanic peoples in particular in Europe, and perhaps the Druids, where they were worshiping nature in forests. And because the average lifespan was only 20, 25 years of age, reproduction was really important. People lost their mates very young, but they still had reproductive potential. So the idea of being able to recouple was then institutionalized into forest worship with these rituals of psychoactive meads. The church saw this as a threat to monotheism, and so they banned mushrooms, henbane, and magical plants from beer, and the Bavarian Beer Purity Act codified this. So they could only have hops, sugar, malt, and water and yeast. Of course, there's wheat in there too. So these mushroom stones have been found in the western slopes of Guatemala. The conquistadors, when they came over in the early 1500s, the edict from the Pope is to destroy all idols. These were thought to be idolatry. They brought over an extraordinary number of diseases. The population was described as being immunologically naive. They had no history of contact with syphilis. Tuberculosis is questionable, but certainly not smallpox and many of the flu viruses. So they were devastated. The shamans could not protect their people. The shamans lost face, and the Christians then promised everlasting life, something that was new to them, if they converted to Catholicism. And then they pressured the converts then to snitch on their neighbors. And so these mushroom stones were hidden from view and destroyed by the thousands with sledgehammers by the Catholic priests in the center of cities. And then the mushroom cults went underground for fear of persecution. So these were largely found by farmers, in the past 100 years, tilling their fields. And they'd pop up these mushroom stones out of the ground. This one at Sotheby's here is sold for $1.2 million. I'd like to mention it because I called them up before it went up. And I talked to the curator of the Denver Museum, and I said, what is this little character holding? And she goes, I don't know. It's a big debate. And I go, well, do me a favor. And I said, do you have it nearby? He goes, yeah, it's right in front of me as I'm talking to you. Do me a favor and look underneath the little cap here and tell me if you see ridges. And she turns it over and goes, yeah, there's a bunch of ridges. I go, do you ever think they were mushrooms? Dead silence, right? Again, hiding in plain sight. That which is so obvious is invisible to those people who are blinded to the possibilities. I'm honored to be the temporary custodian of 17 mushroom stones. They've come to me over the years, twice through the wills of both kinds of fathers who died, said Paul Stamets understands the significance of these. This is what they're worth. They were sold on the art market, still being sold today. They're banned, of course, from being taken from Guatemala. I fully intend to return them to Guatemala. That's in my will. But I've had 2 Guatemalan officials who've been friendly to me, who've come to visit me, says, don't dare return them to the Guatemalan government. They'll just sell them off until they corrupt. In my will, I want a ceremony where these mushroom stones are returned to the Mayan people on a Mayan temple. That's my will. But if I can find the right Mayan group, so any indigenous people out there, I am looking for the right people to preserve and protect this so they won't sell them off. So I just got another mushroom stone, just came to me in the past week. So I'm up to 18 of these. There's only 200 in the world. So a shaman came to visit me, and he's been to some of these conferences, and he saw them all in boxes. And he goes, Paul, that's not right. I said, what? I said, I'm worried about earthquakes. And he goes, these want to be out. These want to breathe. You have them captured in little cardboard boxes with all this foam around them. But I'm terrified they'll break on my watch. So I listened to him and I said, you're right. So he left. I had this epiphany and I put him in a circle. And when I put these in a circle, it reverberated. And the one in the center is 2,500 years old. I have a provenance on that from Peter First. The other ones, they went through 2,500 years to about 1,500 years ago. When I put them together, I have a community. I have a community of Mayan shamans. And I walk by them every single day. They're right in my living room. They've taken over my living room. And so I feel now the pulse of history, of shamans. I feel like I'm truly a messenger, carrying ancient knowledge and advancing it forward for future generations. So this is what fuels me. This is what I see constantly every day.